Alright, so let's take a look at what the general form of a quadratic equation looks like. So I've written it up here at the top of the screen for you, and what it is basically y equals ax squared plus bx plus c. Now a, b, and c are the three parameters in this form. Let me give you a numerical example of what the general form might look like. So it might look like 3x squared minus 2x plus 4. So how do we interpret this this form? Well, the sign of a will tell us whether it opens up or down. So when it's positive, so when the sign of a is positive, we have an upwards opening parabola. So this is positive, and when it's negative, it's going to be a downwards opening parabola. And also, parameter c is the y-intercept. So we know right away from the example over here that the parabola will cross the y-axis at 4. So a quick sketch of this, it might look like this, where it opens upwards and the y-intercept here is 4. Now, you're familiar with the standard form, which looks like this: y equals a x minus h squared plus k. And let me give you a numerical example of the standard form. So let's say 3x minus 1 squared plus 2. So you know right away that the vertex of this parabola, vertex v, is at 1, 2. And the reason you know this is because you have your h and k right here. H and k. Of course, don't forget to take the opposite sign that's in here. Now let's see how we can convert from standard form to general form. So to convert from standard to general, what we do is expand. So we're going to expand. Expanding goes like this. So we have y equals 3 times x minus 1 times x minus 1 plus 2. And now we FOIL, we distribute the two brackets one with the other. And that gives us, very quickly, gives us x squared minus 2x plus 1 plus 2. And now we're going to distribute the 3 into your bracket like this, and we're going to get 3x squared minus 6x plus 3 plus that 2, and then we group the last two terms together, and finally we have y equals 3x squared minus 6x plus 5. So essentially, your standard form, which was this over here, after expanding it, you get this general form. So to go from standard to general, all you have to do is expand. Alright. Now from this form over here, from this standard general form over here, is it possible to go into the zeros form? What I'm asking basically is it possible to factor this, put it into factored form. So factored form, just to remind you, it looks like this: a x minus x1 x minus x2. So are there zeros, first of all, because x1 and x2 are your zeros? And secondly, is it even possible to factor it into two nice brackets like that? Well, let's give it a shot. Let's see. I'm going to factor out the leading 3 because that's going to be my a. So I get 3 times x squared minus 2x plus 5 over 3. And right away I can tell it's not going to factor very nicely because I've got this ugly fraction over here. So I'm not even going to try to factor it. Instead, what I'm going to do is try to find the zeros of this general form using the quadratic equation. Now let me try to remind you what the quadratic equation looks like. The quadratic equation tells you that zeros, which are x1 and x2, is equal to minus b plus or minus the square root of b squared minus 4 times a times c all of which it's divided by 2a. So, my a is here, my b is here, and my c is here. So, when plugging it into the formula, what I get is minus b, so that's minus 6, so 6, plus or minus the square root of b squared, so that's minus 6 squared, minus 4 times a is 3, times c is 5, all of which is divided by 2 times a is 2 times 3. So, from here I can see that I have 6, plus or minus the square root of minus 6 squared is 36, minus 4 times 3 times 5 is minus 12 times 5, that's minus 60, divided by 2 times 3 is 6. This gives me 6 plus or minus the square root of minus 24 over 6. Now I'm going to stop right here because I've noticed that I've got a square root of a negative number, and that's impossible. It's impossible to solve for the square root of this negative number because you cannot take the square root of a negative number. So, from here we can conclude that there are no zeros. So our graph is going upwards. I know that because if we go back to the formula, my a is positive, and according to my delta here, I cannot find zeros, so it's going to look something like this. The other thing I know is that the y-intercept is 5. Here's 5. So it might look something like this. So this is pretty much all that I can do right now with this function. Of course, I can find the vertex, which I know is, according to my standard form, my standard form was over here. Oh yeah, so my vertex was 1, 2. Whoops. So that means that my parabola, I'm going to erase this one and fix it. My parabola should look something like this. So let me get rid of this. The parabola should look something like this. At 1, 2, goes up like this, crosses the y-axis at 5, and there's no zeros. This is 1, 2. So from here what I can do is talk about where it's increasing. So I know it's increasing over here, which means from 1 all the way to positive infinity I'm increasing. I know it's decreasing from here all the way to there, which means from negative infinity all the way to 1 I'm decreasing. I know that the sign of the function is positive for all real numbers because I'm always above the x-axis. I know the minimum of my function, so the extrema of this function is y equals 2. It's the k value of my parabola. And I also know how to go from general to standard form. In the next video, we're going to see another second degree equation, another quadratic equation, and we're going to analyze that one as well and see what we can get out of that.